Welcome everyone, this is the third tutorial video of the regional analysis course, and in this video I'm going to show you how to make some basic and some easy indicators which describe your datasets and measure the volatility of your datasets, which is in this case in the case of indicators in spatial units or spatial subdivisions, measuring the degree of the spatial differences in the observational area. So these indicators are global indicators because we are measure the degree of the spatial differences in the whole observational area. So this is we have only one value for the whole observational area. So this is the definition of the global indicators as we defined it the last occasion. So open the Excel file which is attached in the CoSpace task, and you can see some indicators in Visegrad 4 countries: Czech Republic, Hungary, Poland, and Slovakia. And here is the map of the four countries. These are the Visegrad 4 countries. Here we are the Q33 region in Szeged. This is a NUTS 2 regions in the European Union subdivision system. So the next 5 or 6 months, 5 or 6 occasions, we are going to measure the degree of the spatial differences in this observational area, in this big region, by the NUTS 2 regions. Here we are. We have some indicators which describe the whole observation area. For example, the area, square kilometer, population, 3 different appointment, and unemployed, also 3 different appointment, and the GDP, million euro, is the indicator. GDP, 3 different appointment also. So in the first occasion we just calculate some very basic and very simple indicators, the relative standard deviation and the relative range. But before that we just calculate some basic and simple indicators for the variables, because these indicators and these values are necessary for the calculation of the relative standard deviation and relative range. So first of all, we separate 2 types of the variables, the absolute and the relative indicators. The absolute indicators just count something in the space and something in the given subdivision. For example, the area, which is count the square kilometer, which is count the area, the degree of the area of some subdivision, and population is also an absolute indicator which describe and count how many person and how many people are and live in their those NUTS 2 regions, for example, Central Hungary. There are almost 3 million people in there. And also the unemployed unemployed people, and the GDP in this form, the million euro form, is an absolute indicator. So, but if you just make a division, for example, the population density is a relative indicator for all of the regions, because we have a division in the formula, not just a simple counting in the not just a simple counting. This is a division indicator, and there is a very different formulas for example, the standard deviation for the absolute numbers, for the absolute indicator, absolute variables, for and there is another formula for the standard deviation for the population density, the relative indicators. Okay, let's see how to calculate these indicators for the first case, the area and the population at 2006 and the population density at 2006. I'm going to calculate in this video, but you have to make the calculation all of these indicators. So you have to fill the gap. So you have to fill the gap in the yellow areas, and you have to make the calculation all of these indicators, all of the other indicators. Okay, so let's calculate the first one, the summary. All of the indicators, I will show you the formula. This is the summary formula. Surprise! This is very simple, but that's why I show you, because I want you to get used to the different markings and different mathematical marks in the formulas. Okay, so this is the summary of the this is the summary marker for the this is a summa marker for the summary in the formula. So in this case we summary all of the X indicators from 1 to n, which is the number of the subdivisions. So equal sign and sum and bracket and the area of the area, yeah, and enter. And we have the square kilometer number for the whole observational area. And if you just grab for the left hand side, we have all of the population in the observational area. If you want to see a better form, you can use the thousand separator. Okay, we have 63 million people in the Visegrad 4 countries. So we have in Excel we have also a minimum formula and minimum function. We also, yeah, minimum and maximum also have. Let's calculate the maximum number of area and the maximum number of the population in 2006. Okay, median also have a median function in the Excel. Median is the number if you just make a sorting from the smallest one to the largest one. In the middle number is the median number for the datasets. Okay, and also for the population as well. So the mean is the formula for the mean is just simple. Let's make a summary of all of the absolute number and divided by the number of subdivisions. Okay, and sign it with a line bottom the dataset value or sign. Okay, we have an average function in the Excel also, and mean. We have the average for the area, square kilometer, and the population as well in 2006. So the standard deviation is let's show the formula. It's a little bit tougher than the summary formula. This is a square average difference from the average. This is the official definition of the standard deviation. Standard deviation shows us so in the denominator we just summary the difference, all of the number, all of the absolute value, make the difference from the average, square it, and make a sum in the denominator, and divide it by the number of cases, and root it by but for the absolute values we have also a standard deviation function in the Excel, stdevb, yeah, PA. So this is the right function. There are so many standard deviation function in the Excel, stddev .p, .s, .ea, .p, .pa, but we would like to use the PA function of the standard deviation. Okay, and here we are select all of the area numbers, and this is the average distance from the average, and also calculate it for the population. Range is the difference between the maximum and the minimum value. So here we are. That's why we calculated the maximum and the minimum value. Let's make a difference. Maximum minus minimum. Here we are. This is the range, which describes the difference between the maximum and the minimum value. We have all of the indicators for the absolute value, but for the comparison, two data sets, we cannot use these indicators because we have 10,000 and 20,000 values in the data sets in the area and data set, but we have a million values in the population data sets. But if we have questions about which have highly the higher spatial differences, the area or the population or the unemployment or the GDP, we have to use the relative standard deviation, then the relative range, which is we have to divide it by not the range, the standard deviation, we have to divide it by the mean. And for in this case we have how many percentage, for example, to the percentage form, how many percentage of the standard deviation of the average. And for the population also we have we can calculate for it. So we have also two value in the same category of range, the percentage form, and we can answer the question which has a higher spatial difference. The population has the higher spatial difference in Visegrad 4. So also for the range, divided by the mean, and we have the relative range as well. Okay, but this is the absolute indicators. That's simple, the calculation of the relative standard deviation and the relative range. But for the relative indicators, for example, population density at 2006, we have a very different formulas for example, the mean and the standard deviation. Let's calculate the population density at 2006 people divided by the square kilometer area. Okay. Here we are. We have the population density numbers for all of the regions in the Visegrad 4 countries. We cannot interpret the summary of the relative numbers because these are not counts. These are just a ratio for the population density. So we just not calculate the summary because it doesn't mean any. There is no meaning for the summary for the relative indicators. But the minimum also has the same function. We can use it for the minimum and the maximum also, and the median also. We can use those functions which we used to the absolute numbers. But the mean, we have to use the summary of the population and the summary of the area. So equal number, equal sign, and the summary of the population and summary of the area. Because why? Because we have an average population density to the all observational area, and how to, this is the average number for the population density. How to calculate the population density to the whole observational area? Get the all of the population in the observational area and divide it by the area. So this is if you use the function in the Excel, you just got the wrong answer, the wrong value, because you don't have to use the wrong calculation, but I'm just show you this is the wrong number for the average number for the observation area, because in this case this number this value not doesn't consider the area differences between the regions. Okay, so if you have to make a mean value for the relative indicators, you have to make the division between the summary of the whole observational area and make the division. For the standard deviation, we have also another formula for the standard deviation, the weighted standard deviation. We have also a difference between the mean, but we have to use the f value, the weight value, and divided by this nominator, divided by not just the number of cases, but we have to divide it by the summary of the weight, which in this case the square kilometer area. So the area is the weight, in this case population density. For example, the unemployment rate, which the unemployment rate case, we have to divide it by the unemployed people divided by the population number. So the weight will be the population. Okay. So let's calculate the denominator in this formula. The weighted square deviation is the name of this denominator. So we have to calculate in this cell the weighted square deviation denominator. Okay. The population density minus check the formula. This is the population density for all of the regions, and minus the average. Okay, the average, which means in this case the mean, but we have to fix it because if you just grab it for all of the regions, we have to fix, but because all of the cases the average is in the same cell, and we have to square it, algr 3 and 2, and multiply by the area. This is the formula for the weighted square deviation, and grab it for calculated all of them. And after that, make a summary for the summary row. This is a good cell for the summary. Make a summary. Okay, and then we have to divide it by the summary of the weight, but in this case this divided by the summary of the weight, and we have to make a square root, which is no sqrt. So divided by the summary of the weight and sqrt. Function is the square root. So here we are. This is the right standard deviation for the population density, and the range also just a simple difference between the maximum and the minimum value. And after that, the relative standard deviation and the relative range, also a simple division between the mean and the standard deviation, and between the range and the standard deviation and the mean, and the range and the mean. Okay. So here we are. We just make all of the calculations for the population density at 2006 and the population at 2006. You have to make these calculations for all of the variable, all of the datasets. I just show you how to calculate the unemployment rate equal, and the unemployed people divided by the right population number, 2006 unemployment rate. You have to divide it by the 2006 population and multiply by 100 for the percentage form. So this is the 1.5% of the people are unemployed in Prague, for example, in the Czech Republic. Okay, and for the GDP calculation, you have to make not multiply by 100, just multiply by 1 million, because we have €1 million in the head of the datasets. So we have to divide it by the right population and multiply by 1 million. We have the 60, yeah. Okay, here we are. This is the GDP per capita at 2006. So so for the CoSpace platform, you have to upload just this Excel file for fill all of the gap in the yellow and the green areas. Okay, thank you for your attention.